Hey classes, welcome back. I'm going to go through as quick as I can everything that we did today. There was a lot that we covered, but it's all really cool stuff, especially when you look at the latest news from the James Webb Space Telescope. They're also starting to check out some of the gases in the atmospheres of some exoplanets. They found some carbon dioxide and some methane. We're looking, of course, for oxygen as well, but we're seeing some of the chemical signatures of life. When you look light years across our galaxy and you can see what's in the atmospheres of other planets, what we're learning here in chemistry about electrons, the way they go around an atom, helps us figure out what exists many light years away, someplace that we might never actually be able to visit in person. We can actually tell what's there. It's a wonderful quirk of nature that we can do that. So moving on from that, we started the day with this map right here. We were talking about, it gave me a chance to be silly and talk a little bit about, give some of the students a good laugh, the high school yearbook, when they all look at it and they say, hey, Mr. Forbes, he used to have hair back then and all that. And I'm like, yeah, but it brought up some funny stuff. We were talking about the 80s and 70s styles because next week we have Spirit Week and we have 80s Day, 70s Day, things like that. Also, my yearbook from senior year, 1984 at Cappuccino High School. And a good friend of mine from Cappuccino started off the class in terms of us keeping in touch via Facebook. It turns out my friend Paul Gadassi, who went to Cap back in the 80s, we are up here at 38 degrees north latitude. That's where we live here in the Bay Area, and also Cappuccino High School. Paul, we went to school together. He went off to Cal Poly, and he met his wife there. They moved to her family's home, or hometown anyway, down in Argentina, down here. So we kept in touch. Our daughters, his oldest daughter and my only daughter, we have kids that are about the same age, and our kids are now going to college. My daughter is at Chico studying science, which is awesome. His daughter is at San Francisco State, and the point is, when we would keep in touch, when we saw each other a little while ago, we would always say, hey, happy first day of summer, and he'd be like, hey, happy first day of winter. Opposite seasons. He would have his first day of spring. We would be having our first day of fall. That is happening because of the tilt of our Earth on its axis. Check it out. When you look at an old globe like this, and I do mean old, this one still has the Union of Soviet Socialist Republics on it. You can tell it's a public school globe. Here's the point. If you look at the tilt of Earth's axis right here, they always show when you get a globe it being tilted like this because it is. In other words, if you look at the tilt of our Earth as it goes around relative to the sun, let me turn this off for just a second. If I were to draw the Earth up here on the board, you might remember, and this feeds into our moon observation, as I get tangled in my cord right here, feeds into our moon observation. If the Earth was roughly that size, the size of a basketball we had figured out using ratios in the back of the room, on the big chalkboard that I'm pointing at back there, our moon would be roughly, got a little bit big there, the size of a tennis ball compared to a basketball, roughly that size. Mars, however, about a third right here, does have a couple of moons. It's got two moons, Phobos and Deimos, but Mars's moons are so tiny they look like orbiting potatoes. They're not even spherical in shape. And if I were to do them relative to the size of Mars, if I drew it like this, they'd be like little dots on the board. Our moon, compared to the Earth, it's almost a double planet system. Some scientists consider it that. Our moon is relatively large compared to the Earth. Based on the best theories that we have, and this is what we talk about in this class, how we know what we know, we think that the moon came from a big impact that happened around 4 billion years ago, back when the Earth was really just essentially a big lava lake. And you're looking at the impact whapping our Earth hard enough to put it at a 23.5 degree tilt. I'll bring up the next board here in a second. And then also our moon kind of stabilized our axis so it doesn't wobble quite so much. In other words, when you look at the moon, make sure you say a big thank you, because the moon basically made a very stable planetary system that kept the extremes of the seasons from getting too extreme. In other words, it gets colder in the winter for us and warmer in the summer, but for the most part, the moon kind of stabilized us quite a bit. Also, as we'll see, we just finished up our moon observation. We went out in first period and saw it today. The moon is mainly responsible for our tides on this planet. And our tides, again, one of the reasons we have big, complicated life on this planet is our tides. So, the things that we're responsible for, that's up on the board. Our tilt of our axis is about 23.5 degrees relative to our path around the sun. And if you're looking at 23.5 degrees, if it wasn't for that, if it was just straight up and down compared to the sun, we would have essentially no seasons here. Also, important to remember, the equinoxes and we talked about, for example, vernal falls. The vernal equinox coming up, you've got springtime. Vernal means springtime in the southern hemisphere, I should say. The autumnal equinox coming up for us here in the northern hemisphere. And we showed vernal falls in a couple of the classes. If you've ever been to Yosemite National Park, vernal falls gets its name because it's at its most spectacular in the springtime when you have all that beautiful snow melt cascading over. When you see vernal falls in the autumn, it's generally much, much smaller, a little trickle coming over, if anything, this time of year. You see a spectacular snow melt pouring over it, though, in the springtime, which is great. Highly recommend you get to the Mist Trail and check that out if you can. So that was the observation part of the class today, checking out the moon, checking out the shadows. We saw the shadows are getting longer outside when you compare them at the same spot, at the same time, day to day. And then finally, we started getting back into a little bit of chemicals, chemical equations versus, or chemical reactions versus nuclear reactions. In class today, we took good old table salt. Here's a petri dish full of table salt and a couple of cups, and we filtered salt water through a paper filter like this. And we wanted to challenge students to guess, first of all, how much of that salt do you think you'll get back by mechanically filtering it out? And as you probably know, we started at first, maybe a few stray pieces of salt came on through, but for the most part, none. You can't really get salt from physically filtering water like that, no matter how fine your filter is. When you look at our third year of drought here in California, we are 500 meters in this classroom from the ocean, the largest physical feature on the surface of the planet. All that water out there in the Pacific Ocean, you might be saying, how can we be in a drought when we're next to that much water? Salt water. Now you can desalinate salt water, but it takes a tremendous amount of energy. Water has a tremendously high heat capacity, we call that. Basically, partly because of its polarity. It's that plus side and its minus side. It does not like, if you will, to change temperatures. It likes to stay the same temperature. That's partly the reason why Pacifica has such a very small temperature range over the course of the year. But the long and the short of it is, more on the unique properties of water as we go throughout the year. This polarity, remember, also gives water its unique property of getting less dense as it freezes. So ice floats and liquid water will be underneath the ice. Very, very important for life on this planet. So chemical reactions are all about electrons and sharing or losing or gaining electrons. Nuclear reactions have to do with the inside of the atom, the protons and the neutrons. That was one of the big takeaways from this. By drawing on the board, and we showed a little illustration, about 5 minutes, of salt being surrounded by the sodium and the chlorine atoms, being pulled apart and surrounded by those polar water molecules. You can see the chemical reaction of water being polar, pulling apart a compound like salt. A nuclear reaction is different. Nuclear reactions actually change what your element is. That's a big deal in terms of understanding, for example, radioactive decay. One of the huge pieces of evidence for evolution as we go through this class, as we go through selection, natural selection, artificial selection, we are going to be looking at rock layers and different fossils. How do we know the age of those fossils? First, there's relative dating. The ones on bottom tend to be older than the ones towards the top. But one of the other ways that we know how old things are is by understanding radioactive decay. So next week, one of our labs will have to do with the radioactive decay, doing the curve of how certain elements decay, and it gives us a clue to how old certain fossils are. So that was the quick recap of what we did today. Please look for the notes online. Don't forget, if you do the coastal cleanup, send me a picture and I'll get extra credit for the coastal cleanup. If you can't do one of the formal coastal cleanups where you're out there with a crew, myself or Mr. Westbrook or any of the teachers, if you can't make one of those, I understand we all have busy schedules, there's a lot going on. If you go out to the ocean and show me a picture of some of the plastic you've picked up, that's one of the polymers we're going to be talking a lot about this year. Remember, our oceans are getting choked with plastic right now, and one of the most important things that we can do is try and prevent the plastics that are around here from getting to the ocean. Remember, the ocean is downhill from everywhere, and especially here in Pacifica, especially in this classroom. We're 500 meters from the gorgeous Pacific Ocean. It's our job to protect it. So being a Friday, have yourself a great weekend, and I'll see you in class and online. Take care.